Okay, good morning, everybody. All right, so picking up from the end of the last lecture, I was telling you about the command history that Bash has as one of its features. And so Bash remembers the sequence of commands that you typed in previously up to a certain point, and you can use the history to access commands that you've previously used before. It has another nice feature too called tab completion. Assuming that it's turned on in your shell, for almost all of you it's going to be turned on by default. And so tab completion lets you save some typing. So for example, suppose you wanted to type in some command, like cow say, right? So I can type in the whole command if I wanted to, right? But Bash is aware of the commands. Bash is aware of the commands that exist on your system, and so you don't have to type in the whole name of the command. You only have to type in as many characters as you need to uniquely identify the command. So on my computer, there aren't many commands that start with cow. So I can type in cow and then press the tab key. Oh, this one, there's a couple at least, right? So if I press it twice, you see that it'll tell you there's two commands. There's one called cow say and there's one called cow think. Turns out they're both the same, more or less. So if I press the S and then press tab, Bash will automatically complete the name of the command, which is nice. So I don't have to type in the entire command name. Now, the other thing that you can use the command line tab completion for is to complete file names. This looks like I'm in the assignment 1 directory. Okay, so let me find, okay, so there's a file called a1solutions.txt right here, right? And so suppose I wanted to see what was in that file, right? And so one way to see what's in that file is to use the cat command, which I showed you on day 1, I think. Right, so remember, cat concatenates the contents of a file and displays the output to standard output. So I can type in, sorry, I forget this name. Okay, so I can type in the whole thing, right? And apparently there's nothing in the file. Let me find something that actually has some, well, all right, so, right, but instead of typing in the entire name, you could also use tab completion on the names of files. So if I look at the names of the files in this directory, there's 2 that start with a capital A. There's only 1 that starts with A1. So if I type in A1 tab, Bash will automatically complete the name of the file and now I can just press enter to run the command. Right, and so the tab completion will save you a lot of typing, or can possibly save you a lot of typing on the command line. Right? It'll let you complete the name of files and it'll let you complete the name of commands. Right? If the command line completion cannot uniquely identify the name of a file or the name of a command, right, it'll do nothing. But if you press it a second time, it'll then tell you what are all the possible completions, right? And now you can pick which one you want. So I can look at, I need a job. If you press tab there, it'll show you everything that's in the directory. And she submitted something called myanswers.txt, and that's the contents of the file there, right? So handy feature, obviously not good fodder for asking you questions on a test or exam. But anyway, it's useful if you're using the command line. Okay, the lecture now wants me to jump into the notebook for something that's not in the lecture slides. So if you jump to the commands notebook, towards the bottom of the notebook, it tells you about lists of commands. So a list of commands is a sequence of one or more commands. And you separate the commands with one of these symbols here. So you can use the semicolon, right? You can use the single ampersand, you can use the double ampersand, and you can use the double vertical bar. The semicolon is similar to the semicolon in Java, right? It basically ends, well, in Java it ends a Java statement, right? In Bash, it basically separates a list of commands, right? So if you wanted to run 2 commands in a row, you can command 1, semicolon, command 2. It'll run command 1, wait for command 1 to finish, and then it'll run command 2. Right? So if you want to, you can put multiple commands on the line, separate them with a semicolon. Right? The ampersand does something that you'll never need to use in this course. So the single ampersand after a command runs the command in what's called a subshell. So what it does is that the shell creates a new shell, launches the command in the new shell, and then the shell becomes responsive immediately to whatever else you want to type in. Right? So if you have a very long running command, which you might have if you try to start up a separate piece of software from your shell. Right? So from my shell, I could perhaps start Eclipse if Eclipse was installed on my computer. It's not installed on my Linux, so I can't do it here. Right? But if you start up Eclipse without the ampersand, what might happen is that your shell will start Eclipse, and then you won't be able to use your shell for anything else. If you type something in, nothing will happen. And the reason that nothing is happening is because your shell is waiting for Eclipse to finish, so for you to close Eclipse, before it will respond to any other commands. So if you want to start a long-running process and have control of your shell again, you can type in the command, follow that up with an ampersand, and away you go. The double ampersand and the double bar do something based will execute a sequence of commands depending on whether the previous command succeeded or failed. Right? So here's an example here. So remember what cd tilde does, right? That changes to your home directory. That command should always succeed. If it doesn't, there's something unusual about the way you've set up your home directory. Right, so that should always succeed. Right? If you follow that up with ampersand, ampersand, and then ls, right? What that will do is it will run the ls command after running the cd tilde command and assuming cd tilde actually succeeds. Right, so this should work just fine. This should switch to my home directory and then list the contents of my home directory. So if I run that, it does exactly what you expect it to do. The or, oh, sorry. Now, if the first command does not succeed, in other words, if it encounters some kind of error, and I'll explain to you how bash detects whether or not an error has occurred later on. Right, so if that command does not succeed, then the command after the ampersand will not run. So I don't think, I guess I should check. I don't think I have a directory called dirname in my home directory. Well, I lie. I do have a directory called dirname. So let me remove dirname. Okay, so I no longer have a directory called dirname in my home directory. And so now if I type in cd dirname, sorry, and ls, right, switch to the directory called dirname and then list the contents of the directory. If the previous command was successful, right, it doesn't execute the ls command. Right? So instead, you get the error, right? Can't switch into that directory because it doesn't exist, right? And then ls does not run, right? So the ampersand lets you conditionally run a command if the previous command succeeds. The or does something similar. So the or runs a command, runs a subsequent command if the previous command failed. So here, same example, right? There is no directory called dirname, so cd is going to fail. Right? If it fails, right? So the double bar means if that command fails, run this sequence of commands. Right? So here we've got a list of commands followed by, we have a list of commands that will run assuming the cd command fails. Right? So basically what they're saying is if dirname does not exist or if you can't switch into that directory for some reason, right? I'm going to make a directory called dirname. I'll explain how to make directories probably in the next lecture or the one after. Right? I'm going to make that directory. I'm then going to switch into that directory, and then I'm going to print the name of the directory. Right? So I know dirname doesn't exist, so there's your error, right? Dirname, right? No such file or directory. So that failed. So now we make the directory, switch into the directory, and then print the name of the working directory. And you can see that we're now in the directory dirname. So that's lists of commands, right? Semicolon lets you separate individual commands. Double ampersand and double vertical bar will conditionally run a command depending on the outcome of the previous command. All right, if you are tempted to use the double bar or the double ampersand or the single ampersand in assignment 1, then you should probably rethink your approach. You don't have to use them for assignment 1. No question assignment 1 requires their usage. Oh, wrong class. Let's see. Next lecture. Oh, yes. Okay. Now, assignment 1 does require this part. So you'll need this. You'll also need something from the next lecture before finishing off assignment 1. Slideshow here. Okay. So path names or file names are, well, they're fundamental to the command to using a command line interface, right? Everything that all the data that you are manipulating probably comes from a file of some kind. So you need to be able to specify file names. Now, you know that one way to specify a file name is to type in the entire file name, right? That becomes tedious, especially if you have long file names or if you have a lot of file names that have a pattern of some kind. And so the shell has a way to specify groups of file names by using what are called wildcards or globs, right? Globbing patterns, globs, they all mean the same thing. Basically, if you ever see the term glob or globbing pattern, people are referring to this use of wildcards to specify file names by pattern. Now, one of the things you have to watch out for in Bash is that, sorry, not in Bash, in Unix, is that Unix says a file name can contain any character except for the /, right? Because the / is your directory separator. So it can contain any character, which includes weird things that you normally don't see, like new line characters or tab characters, or any other of the special characters, like a backspace character, right? And it can contain characters like $, ampersand, and any other symbol that you can type in on your keyboard. So you have to watch out a little bit for that. I'll explain how to deal with those cases a little bit later in this lecture, right? But to specify a pattern of file names, you can use, you can combine stuff that you can normally type in, so regular characters and symbols, right? Plus the star, the question mark, the square brackets, and the square brackets have a few different structures that we can talk about, right? And so when you use a star as part of a file name, that means the star means match any number of characters, including no character, right? So the star can be used to replace any sequence of characters, right? Any sequence of 0 or more characters. The question mark can be used to replace any single character, right? And I'll explain with these, what the square brackets let you do in just a second, right? So star. So if I use star as a file name, that matches all files, all non-hidden files, unless you've configured your shell otherwise, right? So star on its own matches any sequence of characters, therefore it will match any, it'll match all files, right? So if I go to my command line, right? So there's ls. Remember what ls will do if you specify a file name, right? It'll tell you information about the file itself, right? Suppose I wanted information about all the files that start with s, right? I can type in lsf star, right? And that lists all of the file names that start with f, right? If I type in ls star, that matches all the file names that matches all file names that are non-hidden, right? And so notice it spits out information about all of the files and all of the directories in my home directory. So there's the star, right? And you can cook up all sorts of patterns using the star, right? So a star matches all file names that start with the lowercase a, right? Star.text, so star means match everything, right? Followed by a dot and then followed by txt. So that will list all the files that end with .txt, right? A star.txt will match all files that start with an a, end with .txt. Right, and so that's what the star does as part of a globbing pattern, or as part of a glob, right? Okay, what about the question mark? So the question mark matches any single character, right? So the single character does not include the empty character, right? So there's no empty character. So question mark will match any 3-character file name, right? So any file name containing 3 characters, you can match as question mark. X $Z means any file name that starts with an X, followed by any character, followed by a Z, right? It does not match XZ, right? But it will match any 3-letter character, any 3-letter file name starting with an X, ending with a Z. Right? And so if we go here, let's see what, okay, we've got a bunch of directories that end with a number. So I could do something like ls_dir question mark, and that will match dir 1, 2, and 3. Right? So nothing in dir 1, nothing in dir 2, nothing in dir 3. Right? Does not display information about dir 0, 0, 0, 1, 0, 2, because those don't match the pattern. What else? We have a bunch of files, right? They're called file number. So file number star, I can combine the question mark and the star together. Oh, this is not good, sorry, file.txt like that, right? So that will find all the files that start with the word file, followed by any single character, followed by .txt, right? Here, right, down here, right? And there you go, so it lists all those files there. Okay, what do the square brackets do? So the square brackets will match any single character inside the square brackets, right? So any one character, right? Not any sequence, but any one. So square bracket, little y, capital Y, 1 and 2, right? With an X and a Z before and after, will match any file name that starts with an X, ends with a Z. Sorry, can you see the mouse? Yeah, you can, okay. Starts with an X, ends with a Z, and in between is either a little y, a capital Y, a 1, or a 2. So it matches those 4 file names there. Right? And so the square brackets define what's called a character class, right? Match any single character from within that class. Depending on your shell, you can specify a class using a range, right? So A-Z means any character between A and Z, right? So little a, little b, little c, all the way through little z. You have to be a little bit careful when you specify the ranges to make sure that's always the smallest character in the range, that's always the largest character in the range. So this will match any character that any file name that starts with an X, ends with a Z, and has a lowercase English letter in between, right? XAZ, XBZ, XCZ, X all the way through XZZ. Right? 0 through 9 will let you match the digits 0 through 9, right? So X0Z, X1Z, X2Z, up to X9Z. Right? If you have a bunch of PDF files in your directory that start with 2 digits, you can match those by saying square bracket 0 through 9, square bracket 0 through 9 dot PDF, right? And that will match any file name starting with 2 digits and ending in .pdf. Oh, I missed a few things. So let's go back. So using these, do I show you here? Oh, I do show you a few other examples here. All right, so let me go back. So instead of specifying the characters that you want to match, you can specify the characters that you do not want to match, right? So for if you want to specify a pattern where you do not want to match certain characters, that's the exclamation mark inside the square brackets, right? So square bracket, exclamation mark, some sequence of characters will match any single character that is not inside those square brackets, right? And then there's something called a POSIX character class, which looks like square bracket, colon, some name here, colon, square bracket, square bracket. I'll show you that in just a second. Right. So the POSIX character classes, here are some of them. There are more. These let you specify predefined, I guess, sets of characters. Right. So square bracket, colon, al_num is all of the alphanumeric characters, right? So anything that looks like a letter or a number. Right? Square bracket alpha, anything that looks like a letter. A square bracket, colon, digit, colon, anything that looks like a single digit. When I say number, I guess I mean single digit. Right? Colon, lower colon is all the lowercase letters. Colon, upper colon is all the uppercase letters. And there are additional character classes as well. I don't remember if the notebook lists them or not, but you can always look them up and just look up POSIX character class and you'll find them. Okay, so here are a few more examples, this time using the exclamation mark and using the POSIX character classes, right? So now, one of the things you have to remember when you're using the POSIX character classes is the square bracket is part of the character class name. So square bracket, second square bracket, colon, upper colon, square bracket, star, right? Matches any file name that starts with an uppercase letter, right? Anything starting capital A through Z can be matched that way. You could also use square bracket big A hyphen big Z square bracket. That would also work. Right? If you use the exclamation mark, right, that negates anything anything else in the inside this character class here. So anything that's not an uppercase letter, right? So any file name that does not start with A through Z, right, The star lets you match all the other characters. All of the following characters, sorry, will be matched by that pattern, right? X, square bracket, digit will match any file name that starts with an X followed by one digit, right? So X1, X0, X1, X2 through X9. Oh, okay. And so that's a very quick tour of the globbing, of the globs in Bash. All right, any questions so far? Super. All right, what's the next? 3. Okay, so I think we jump to a notebook now. So that's the command notebook. We're done with that one. File name expansion. So the file name expansion is the notebook that corresponds to what I just talked about. So it tells you about your globs or your wildcards. Right? So if you want to review, or if you want more examples and more runnable examples, for example, you can just run the notebook. Oh, sorry, that's my phone. Hang on. That's not anybody I know. Okay. And so it does look like all of the POSIX character classes are here, and there are more examples that you can run in the notebook. File name expansion. Where is? Okay, so now we're going to quoting. All right, so you need this notebook for some of the early questions, or to help you solve some of the early questions in the assignment. Right? Okay, so you've already seen, right? So I just showed you stars, question mark, the square brackets, the exclamation mark, right? These are all symbols that may or may not have special meaning to the shell, right? Some of them do, some of them, it turns out, don't actually have special meaning, right? So anything, so as I mentioned before, Unix lets you use any character as part of a file name except for the /, right? And so if a character has a special meaning to a shell and it happens to appear inside of a file name, you might imagine that the appearance of that character or that symbol might have unusual, might cause unusual things to happen, right? So for example, if a file name has a star in it, you know that the star matches any sequence of characters, right? And so how do you specify that you only want to match just the star, right, inside of a file name, right? Similarly, the space is very common inside of a file name, especially for people who are used to working in Windows or Mac, right? It's very common to have file names that have spaces in it. The space is important in Bash because Bash uses the space to separate either commands or arguments, right? So it's what's called the word separator in Bash. Okay, so I guess there are a bunch of characters that are significant to this shell, right? So the first thing in this notebook is this code, which shouldn't make any sense to you right now, right? So if you read this, don't worry, and you don't understand what's going on, don't worry about it. In a couple of weeks, hopefully you'll be able to decipher what's going on here, right? But this little program here will actually print out all of the symbols listed here, right? And then it will, yes, all the symbols listed up there, and then tell you which one of these are significant to the shell, or you need special handling, right? So, does the % need special handling? No, you don't have to worry about the %. Plus, no, minus, no, dot, no, right? That might surprise you, right? You can, in fact, use a dot inside the middle of a file name, even though you know that dot and dot dot exist, right? The / is not, you don't have, it does not need to be handled separately. It's the directory separator in Bash, right? Colon does not need to be escaped, right? Equals @ underscore. None of these need special treatment, but a bunch of them do, right? So if your file name has a space in it, which I can't highlight, right? That needs to be handled specially. Exclamation mark, the quotes, $, ampersand, and all of these other things need to be handled specially, right? And so all of these other symbols here, if they appear in a file name, they need special treatment, right? One way to deal with them is to put the / character in front, right? And so don't confuse the backslash with the forward slash, right? The backslash means something is not the same as the forward slash in bash, right? The backslash character is what's called the shell escape character, right? And so all that means is that if you put a backslash in somewhere and follow that by another character, any one character, right? The backslash preserves the literal value of the next character, right? And so if you have a special character or a symbol in one of your file names, like a, say, $, right? So if $sign is part of your file name, then inside your, when you go to specify the file name, you can always write $, right? Backslash means don't treat the $sign as being special, treat it as being part of the file name, and away you go, right? Okay, hang on, while I go back up to the top, I need to do this. All right, and now I need to do this. Okay, so I'm now in a directory that has some specially created files, right? So it's got some files with some special characters in them, right? So here you can see this one has a star in it, one has a question mark in it, and one has a file with a bunch of spaces in the name, right? Oh, and it's got some other stuff here too, apparently, probably from a previous year when I ran this notebook, right? So that's all of the files in my directory, right? Notice that when it lists, at least for my version of bash, right, when it lists a file with special characters in the name, it puts it in single quotes, right? So keep that in mind, right? The single quotes are not part of the file name in this case, right? So the single quotes are here only to indicate that this is a file. This file name has some unusual characters in it. All right. So suppose I wanted to look at the contents of that file there, right? So let me do this from my shell, assuming I can find this notebook. Where is this? This is in scripts and is it here? No. CD. Where do you think I put it? Sorry, just script quoting. Okay, I guess that makes sense. Okay, so I've got file with star in name. So if I wanted to look at what's in that file, I could do cat, and then I could start typing in the name. Okay, so suppose I do that, right? I want to look at the contents of that file. Oh, sorry, of that file, right? Now remember, what star means when you use it as part of a file name, right? It's a glob. So that will match any sequence of characters, right? So it will match the star, right? But it's also going to match that question mark, right? And so when I run cat, what's going to happen is it's going to display the contents of that file and the contents of that file, right? So the contents of the first file say to avoid using a star in your file name because it causes problems like this, right? The contents of the second file say avoid using the question mark in file names, right? The exact same thing will happen if you change that star to a question mark, right? Remember what the question mark does, matches any single character, so it will match that star and it will match that question mark and you're going to get the same output, right? And so what's the solution here? If I just want to look at what's here, right? Well, I need to tell the shell, hey, that star is special. Okay, so one way to do it, backslash in front of the star, right? And now it just lists the contents of that one file, right? Avoid using the star in the file names, right? Backslash means don't treat that character as being special, right? And so this only displays the contents of file underscore with underscore star underscore in name, right? And the same is true if I just want to look at, if I want to look at the contents of only file with question mark in name, right? Are there other ways to handle this problem? The answer is yes, right? So what else can you do? Well, I can, instead of escaping the special character, right, I can wrap the entire file name inside of double quotes. You don't have to wrap the entire file name. You can just wrap the special character in double quotes, right? So that works too, right? Similarly, right? So like I said, you don't have to wrap everything, right? You just need to wrap the special character, right? So double quotes works nicely. Single quotes will also work in this situation, right? But there is a difference between the single and the double quote. So in this case, they all work, right? This is why the notebook is called quoting. Right. Okay, let's see. So there is using the escape character. Oh, the same is true with spaces, right? So if I wanted to look at the contents of the file with spaces in names, right? Cat file with spaces in name. Okay, so what happens if I do this? Right? You get back this weird error. It says there is no file called file, there is no file called with, there is no file called spaces, right? And that's because the space character is used to separate the arguments to the command. So cat thinks you want to look at the contents of file and the contents of with and the contents of spaces and so on and so on and so on, right? It doesn't know that it doesn't think that that's all part of a single file name, right? So solution, well, wrap the whole thing up in quotes, right? Or put a backslash in front of every space if you wanted to. You know, if you use command line completion for this, so tab completion, this is a space, so I have to do something like this, right? So when you do tab completion, it will automatically insert. In this case, it automatically inserts the backslash space for you, right? And that does what you want, right? I'm not sure if it always puts in a backslash or if it'll sometimes quote. I don't remember now. But anyway, if you use tab completion and you can actually match the file name properly, the tab completion will take care of either the quoting or the character escaping for you. Okay, so there is a difference between single and double quotes. For the purposes of assignment 1, I don't think it matters what you use. Single quotes basically turns off the special meaning of everything inside of the single quotes, right? So single quotes preserves the literal values of all the characters within the quotes, right? Now, there is an implication of this, right? If your file name has a single quote in it, you cannot use the single quote to get rid of the single quote or to take away the special meaning of the single quote, right? So what Bash will do is it'll look for the first single quote, then it'll look for the next single quote, and it'll think everything in between. It'll take away the special meaning of all the characters in between, right? And so there's no way to escape a single quote using just single quotes, right? The backslash character also has its special meaning removed from inside single quotes, right? So if you wanted to, in all these examples, wrapping the file name or the special character with single quotes takes care of the problem. Double quotes are slightly different. This version of the notebooks has a bug in it, and I'll explain that in just a second, right? So double quotes takes away the special meaning of all the special characters except for the $sign, the backtick. So we're never going to use the backtick in this version of the course, but it takes away the special meaning of the backtick. And it can take away the special meaning of the exclamation mark if this thing called history expansion is enabled in your shell, right? Sorry, it preserves, except for, that's right. Now, this looks funny, right? And it's because there's a bug in this notebook. So the notebooks are written in a language called Markdown, right? Markdown, well, it's a language, so it has special characters in it. One of the special characters in Markdown is the backslash. And so when I put the backslash in here, I need to escape the backslash. And so that really needs to be backslash. And there it is, right? So double quotes will also strip away the, you can use a backslash inside double quotes and the backslash is still significant, right? However, the behavior of the backslash is modified, right? So the only characters that are escaped using backslash are the $, the backtick, the backslash itself, and the double quote and the new line character, right? So be careful if you're using double quotes and you want to escape something inside with the backslash, it may not work the way you expect it to, right? So double quoting in Bash is very common to prevent word splitting, right? So if you have a file name or a string that's got spaces in it, and you don't want the individual words in that string to be treated separately, it's very common to double quote that string. Right, so just like before, I can double quote those file names with the special characters in it, and the problem will go away. Right, so for example, if I cat the contents of that file to standard output, right, you get just the contents of that file. Right. All right, so there's quoting. That will get you through the first few questions of assignment 1. Right. And we're now into another notebook. So notice that the notebooks are not like, it's not one notebook per lecture. Right. I can often get through more than one notebook per lecture, and sometimes it'll take 3 or 4 lectures to get through a single notebook. Right. I think I'm supposed to jump to, I'm going to jump to permissions. Well, sure, let's jump to permissions. There is a question, 2 questions on the assignment that require permissions. There's a question that requires you to write a pipeline. So I want to get through these notebooks as soon as I can. I'll come back to creating, moving, removing, and copying files. All right, permissions. So Unix, or Unix-like operating systems, they were originally designed for multitasking, multi-user systems. So multitasking means more than one thing is running on the computer at a time, or at least the illusion of the more than one thing is running on the computer at a time. Multi-user means there are multiple users accessing the same computer at a time. That's not the way most of you use your computers at home, right? Most of you, it's single user, right? Multitasking, but single user, right? Many of the early computers that ran Unix, they were meant for multiple users at a time, right? Now, if you have a bunch of people using the same computer at a time, right, it's probably a good idea that each individual user has some control over their own files. Right? So I shouldn't be able to look at your files, for example, on a multi-user system. Right? You shouldn't be able to look at my files unless we grant each other special permission. Right? Similarly, it's probably a good idea that you and I can't look at the special operating system files. Right? So it's probably a good idea if I can't go into the root directory and delete the entire root directory. Right? Because that'll blow up your entire operating system. And so Unix introduced this idea of permissions on files, right? Or access rights, if you want to call them that, right? So in Unix, there are 3 separate groups of people, users, sorry. There's a group called user, right? So that, there's a person called user, right? There's a user called user. The user is the owner of a file, right? So every file in Unix has a username associated with it. Right? When I run ls in my command, in my shell, with the -l option, right? That name there is the user of the file, right? Of the owner of the file. Okay. There's also something called a group, right? And so every user belongs to a group. And a file also belongs to a group, or groups, I think. Is that true? I don't remember. Anyway, multiple users can belong to a group. So you can group different users into things called groups, right? And every user belongs to at least one group. Modern Linux distributions will create a group having the same name as the user whenever you add a new user to the system, right? So here, that second Burton is the group associated with that file, right? That group has the same name as my username. So groups, to create a group, you have to have system administrator privileges. We're not really going to create groups in this course, right? But if you want to know anything about system administration, so if you want to learn about system administration, or if you learn about system administration, you will eventually come across this notion of groups and how to create them. Right? We're not going to create them here. And then finally, there is this group called other. Right? So any user that's part of other, so not an owner or not part of the group associated with the file, falls in the class other. Okay, I gotta run that. Okay, I'm gonna run that. Great. And then I'm gonna run that. Okay. So when I run that command with the -l option, I get a bunch of information, right? And so that information that it's showing you there, the part that we're interested really is this stuff here for this notebook, right? So that stuff there tells you the permissions that are associated with this file, right? So the first hyphen is the file type, right? So the file type, in this case, it's a hyphen, so that means it's a regular file, right? The next three characters, so RW hyphen, are the permissions that the user has for this file, right? So the user is me, right? The R means I can read this file. The W means I can write to this file. The hyphen means I cannot execute this file, or in other words, I cannot run this file like it were a regular program or a regular command, right? So read, write, execute permission. The next three are the permissions for the group, right? So anybody part of the group Burton can read the file, right? They cannot write to the file, and they cannot, oops, sorry, it's really awkward highlighting stuff in Markdown, in Jupyter. And they cannot run the file as though it were a regular program. And then the next three are the permissions that belong to everybody else, right? So everybody who's not me and everybody that's not part of my group, right? They can't do anything with the file. So they can't read it, they can't write to it, and they can't run it like a regular program. The notebook tells you about the other parts of this output. You can read the notebook if you want to know what these are. But it's the permissions I'm interested in here, right? So the permissions are the leftmost symbols in the output of ls, right? Okay, so the first symbol that's output is the file type, right? And there are 7 standard file types in Unix, right? And so those are the 1, 2, 3. These are the 5. This is showing you 5 of them. So these are some of the ones that you might see if you're poking around on your file system, right? For most of you, you're only going to see the hyphen, right? So the first character is a hyphen, that means it's a regular file. If the first character is a D, it's a directory, right? Unless you're poking around your operating system files, you probably won't see L, C, or B in this course. If you want to know what they are though, there they are. And you can look those up if you want to know more information about them, right? So hyphen and D, regular file, directory. The remaining permissions indicate the user group and other permissions for the file, right? And so what I just explained in the previous example, right? So R means read permission is on, W means write permission is on. If there is an X, that means execute permission is on. Do I have anything that's executable? The dir name is probably, oh, sorry. Okay, so that directory does in fact have execute, so I have execute permission on that directory, my group has execute permission on that directory, and everybody else also has execute permission on that directory. Okay, so permissions affect regular files and directories differently, right? So if you have a regular file and you have read permission on that file, right, that means you can open that file and read its contents. Right. If you have write permission on a file, that means you can write to the file, right? Or the file can be truncated. So in other words, you can delete the contents of the file, but you cannot delete the file itself, right? So that's weird, right? So write permission, I can modify the file, but I can't actually remove it, right? Similarly, you can't create or rename the file, right? So just having write permission does not guarantee that you can actually do anything with its file name. Finally, execute means you can run the program or execute it. Run the file as though it were a program or command, or execute it as though it were a script. Okay, now the permissions mean something different if you're talking about directories. If you have read permission on a directory, then you can list the contents of the directory, right? As long as you also have execute permission on the directory as well, right? So execute permission on the directory means that you can go into the directory, right? So you can switch into that directory. So cd, that directory name will work, right? To read the directory, you need both read and execute permission on that directory name, right? Write permission on the directory means you can create files, I can delete files, and I can rename files in the directory as long as I also have execute permission on that directory. We can skip over the rest of this stuff for the time being. It's not relevant to the assignment. At some point, you should go back and look at them just to find out what information is being shown, because you might be curious as to what this information corresponds to. Right? I should probably stop there. So in the assignment, you need to change some file permissions. So I'll talk about how to do that in the next lecture. And that'll let you answer those 2 questions. Turns out it's relatively easy to do. I don't want to start it now because I'm going to run out of time. But we'll pick up with changing file permissions in the next lecture.